Today we are going to be solving absolute value equations. To solve absolute value equations, we can use the fact that the expression inside the absolute value symbol can either be positive or negative. So in order to solve these absolute value equations, the first thing you must do is isolate the absolute value part of the equation. In other words, if there's a number added or multiplied to the absolute value part, you need to go ahead and get rid of that first. The next thing you'll do is set the absolute value expression equal to both the positive and negative solution, and then you'll solve. The final thing you'll do is check your answers by plugging in your solutions into the original equation. Let's look at our first example. It's the absolute value of 2x minus 9 is equal to 15. In the previous slide, I said that we needed to make sure that the absolute value part was by itself, which in this case it is. There's nothing added to it or multiplied. So the next thing we need to do is set whatever is inside the absolute value equal to the positive and negative solution. So we're going to have 2x minus 9 is equal to positive 15, and 2x minus 9 is equal to negative 15. So go ahead and solve that. So we know that we need to add 9 to both sides. So we have 2x is equal to 24. And then to get x by itself, we're going to go ahead and divide both sides by 2. So x is equal to 12. The next part, we do the same thing. Add 9 to both sides. So 2x is equal to negative 6. Divide both sides by 2. So x is equal to a negative 3. Now we need to go ahead and check this. So I'm going to plug these solutions into the original problem. So the absolute value of 2 times my x, which was 12, minus 9 is equal to 15. So let's see if this works. 2 times 12 is 24, minus 9, and the absolute value of that is equal to 15. And I know that 24 minus 9 is in fact 15, so 15 is equal to 15, so that one checks. Let's try the negative 3. Absolute value of 2 times negative 3 minus 9 is equal to 15. 2 times negative 3 is a negative 6, minus 9 is equal to 15. A negative 6 and a negative 9 become a negative 15, but we know that the absolute value of a negative number is in fact positive, so 15 is equal to 15, and that one checks. So both of these are my solutions. So x is equal to 12 and negative 3. Our next example is the absolute value of x divided by 4 minus 2 minus 6 is equal to negative 2. So we know the first thing we need to do is make sure that the absolute value expression is by itself, and in this case it's not, so we need to go ahead and get that by itself. And in order to do that, I'm going to need to get rid of the negative 6, so I'm going to add 6 to both sides. So I have the absolute value of x divided by 4 minus 2 is equal to 6 minus 2, which is a positive 4. So now it's by itself, so I can go ahead and solve this expression. I know I do this by setting each part equal to the positive 4 as well as equal to a negative 4. So I'm going to go ahead and solve this one first on the left. So I'm going to add 2 to both sides. So I have x divided by 4 is equal to 6. And to undo that division, I'm going to multiply both sides by 4. So those cancel, and I'm left with x is equal to 24. I'm going to solve the right equation, so I'm going to add 2 to both sides. So I have x divided by 4 is equal to negative 2. Once again, to get rid of the 4 in the denominator, I'm going to multiply both sides by 4. 4's cancel, so I have x is equal to a negative 8. Now I'm going to check both solutions, so I'm going to take 24 divided by 4 minus 2 minus 6 is equal to negative 2, and see if that solution of 24 works. So 24 divided by 4 is a positive 6, minus 2 minus 6 is equal to negative 2. So 6 minus 2 is 4. minus 6 is equal to negative 2. And we know that a negative 6 plus 4 will in fact give us negative 2. So our solution checks. So I'm going to check with the negative 8 as well. So I have negative 8 divided by 4 minus 2, and that's the absolute value of that, minus 6 is equal to negative 2. Negative 8 divided by 4 is going to give me a negative 2 minus 2. Minus 6 is equal to negative 2. And the absolute value of a negative 2 minus a negative 2 is going to be a positive 4 minus 6 is equal to negative 2. And I know that negative 6 plus 4 is a negative 2, which is equal to negative 2, so that solution checks. So both of these solutions will work. So x is equal to 24 and x is equal to negative 8. If you are working on a problem and you come to a solution that does not work when you check it within the original equation, this is called an extraneous solution. In other words, it's just an extra solution.